Hi everyone, it's Miss Costa here, and in this video I'm going to be going through the November 2021 paper 2 for Edexcel. Okay, so our first question is about inequalities on number lines. Now, all an inequality is a representation of something where you don't know the exact value, but you know that it's larger than or less than or can be equal to something. So let's have a look at this. So we've got a circle that's on top of -1. And an arrow pointing to the right. So an arrow pointing to the numbers that are larger than -1. And the number line tells us that it's a line designated to x. So I know that -1 must be less than what x could possibly be, because x could be 0, it could be 1, it could be 2, 3, 4, 5, 6, 7, 8, 9, 10, it could be a million. Okay, so all I know is that x needs to be larger than -1, or that -1 is less than the value of x. Now, there are two things that you need to know when you're dealing with inequalities. So the first thing is, whatever it's larger than or less than, you do a little circle on top of that number. And the second thing is, if it's less than or greater than, you leave the circle blank. And if it's less than or equal to, you colour it in, okay? So it's a blank circle on -1. So I'm going to say that x must be greater than -1. Okay, you could also write it as -1 is less than x, but generally we tend to write it as x as the subject. Okay, so if it was a coloured in dot above the -1, it would be x is greater than or equal to. So it just depends on whether it's equal to or not. In this case, it's not, it's a blank dot. So we just know that it has to be larger than that value. And over here, we have to show the inequality. So with inequalities, all you do is you're like, okay, I know that y has to be between -3 and 4. So to start with, just draw a dot above -3 and 4. And you know that's what your value has to be between. Now, as you can see over here, it says -3 is less than or equal to. So remember, if it's less than or equal to, or greater than or equal to, then I colour in the circle. If it's just less than or greater than, I leave it blank. So I'm going to colour this circle in. It has to be less than 4, so I leave that one blank. And all I do is draw a line between the two. And that's it. That's how I show that inequality. Okay, so in this question, you're being asked to find the highest common factor of two numbers. Now, a factor is just a number that multiplies into that number. So, for instance, the factors of 10 would be 2, 5, 10, 1. So any number that multiplies into it. So we want to find the common factor between 60 and 84. And there are a few ways to do this, but I'm going to show you the way using the Venn diagram and factor trees. So what we do is we write out our numbers. So we've got 60 and 84, and we do a little factor tree. Now, the way we do this is by trying to think of prime numbers first. So the lowest prime number would be 2. Then we've got 3, 5, 7, 11. Okay, it just makes it a lot easier. So what two numbers multiply to make 60? Well, 2 and 30. So they're my first branch. Now, when I reach a prime number, I circle it. That tree branch is extinguished, because if I then found the factors of 2, I'd get 2 and 1, and then I'd have 2 and 1 again, and 2 and 1 again, and for 1 I'd be getting 1 and 1. So that's it, that's done. So once you reach a prime number, you've finished. Then you think to yourself, what two numbers multiply by themselves to make 30? Well, you've got 2 again and 15. 2 is a prime number, so you circle it. And then with 15, what two numbers? Well, you've got 3 and 5. So therefore, 60 is can be expressed as 2 times 2 times 3 times 5. 2 times 2 is 4, times 3 is 12, times 5 is 60. So you're just expressing it as a product of its primes. Now, I'll do 84 as well. So 84, again, start with 2 and 42. Let's try it by 2 again, 2 and 21. Remember, I'm circling every time I get to a prime number, and 21 is made up of 3 and 7. Okay, so 84 expressed as a product of its primes would be 2 times 2 times 3 times 7. Now, There are a few ways to do this. I'll show you the Venn diagram way, but then I'll also show you how else you can do it. So I'm just getting rid of the trees because I've already expressed my number. So I've got a Venn diagram here. One that entails all the factors of 60 and one for all the factors of 84. So first we're going to look at factors that are common. So here I've got a 2 that's in common. So I'm going to put it in the intersection here. I've got another 2. So I'm going to put that in the intersection here. I've got a 3. So I'm going to put that there. And then 5 goes here and 7 goes here. So how would you work out the highest common factor using the Venn diagram? Well, it's the intersection. So you multiply all of the numbers in the intersection. So the highest common factor would be 2 times 2 times 3, which is 12. Another way you could have done it without drawing the Venn diagram is just by saying that 60 is 2 times 2 times 3 times 5. 84 is 2 times 2 times 3 times 7. And then anything in common, you circle. So you've got 2, 2, and 3. So you could have just said 2 times 2 times 3. They're the factors that are in common. Okay, but that's how we do the highest common factor. And then the second part of the question is asking you for the lowest common multiple. So once again, there are loads of ways you can do this. You could just, you've got a calculator, you could just, write out 24, 48, blah, blah, blah. And then the 40 times table is 40, 80 until you've come across the first common multiple. And that's one way you can do it. But I'm once again going to show you the way to do it with the factor trees. So we've got 24. So we've got 2 times 12 makes 24. Circle the 2. 2 times 6 makes 12. And then 2 times 3 makes 6. So 24 is 2 times 2 times 2 times 3. And 40 would be 2 times 20, 2 times 10, 2 times 5, and that's your factor tree done. So 40 would be 2 times 2 times 2 times 5. Now let's look at our Venn diagram again. So let's choose a different colour. You've got 24 and 40. All the factors of 24 go in this circle. All the factors of 40 go in that circle. So what have we got in common? Well, we've got a 2 in common. So I write that in, and I only write it in once because it's common to them both once. Then I've got another 2 that's in common. So I'm going to put that in the intersection. And then I've got another 2 that's in common. So I'm going to put that in the intersection. And then I've got 3 over here that's a factor of 24 and 5 over here that's a factor of 40. So for the highest common factor, I just multiplied the numbers that are in the intersection. For the lowest common multiple, you multiply everything that is in your Venn diagram. So in this case, it would be 3 times by 2 times 2 times 2 times 5. And if you multiplied them all together, 3 times 5 is 15, times 2 is 30, times 2 is 60, times 2 is 120. I know you have a calculator, so you could have done that on your calculator. But that would be how you'd work out the lowest common multiple. And here we've got a speed, distance, time graph. So what's really important about a graph like this is that your distance is your y-axis and your time is the x-axis. Okay, and how do you work out speed? Well, speed, the formula, speed is distance over time. So if you ever forget this, then just think to yourself, what's the national speed limit? Even if you don't know a speed limit, just think of an actual speed. Okay, so national speed limit is 70 miles per hour. Well, what's 70? That's the speed. Miles represents distance. And per hour, per means over, out of. Hour is time. So therefore, speed equals distance divided by time. So that's just a little trick if you forget the formula. But speed is distance over time. So over here, we want to work out Sam's speed in kilometers per hour for the first 15 minutes of the journey. So he starts at 10 and 10:15 would be here. So this is the first 15 minutes of the journey. So how do you work out speed? Well, speed is distance. So what's the distance? We can see over here, the distance is 20 kilometers. And the time is obviously 15 minutes. Now, this is why this question is tricky, because when we deal with time, you're dealing with it per units of an hour. So 15 minutes, we're going to have to express as a fraction of an hour. So 15 minutes, we want to write out of 60 because there are 60 minutes in an hour. So if you ever get minutes, just write it over 60. So 15 over 60, I can simplify that. You've got your calculators, divide it by 15, that would be a quarter. And a quarter, well, if you don't know how to divide, just type it into a calculator. That would give you 0.25. So 15 minutes is 0.25 of an hour. So what I would do to work out the speed is 20 divided by 0.25. And dividing by 0.25, or dividing by a quarter, is the same as timesing by a 4, but you don't need to know that because you've got a calculator, but it's handy if you do. So 20 divided by 0.25 is going to give me 80 kilometers per hour. Okay, and for the next part of the question, we're just completing the rest of the travel graph. So we're told that at 10:15, Sam stops for 10 minutes. Okay, so on a speed distance time graph, whenever an object is stationary, so whenever a car has stopped, it's represented by a flat line because the car isn't moving, it's not increasing in distance. So as the time goes by, there is no distance increase, it's just a flat line. So at 10:15, that's over here, for 10 minutes, that would take us to 10:25. We want to just draw a flat line. Then it tells me that he drives for 20 minutes at a speed of 75 kilometers per hour. So remember, speed is distance over time. And in this case, I know the speed, I know the time, so I'm trying to work out the distance. So I can just rearrange that formula. So speed, distance, and time. I'm trying to work out the distance. So the distance will just be speed times by time. Okay, now, remember what I said, when we're dealing with speed, distance, time, you have to express the time as a fraction of an hour, as a unit of an hour. So 20 minutes is a third of an hour because, so I write it over 60, so 20 over 60 is a third, okay? So I'm not going to say 75 divided by 20 because that would assume that it's 20 hours. I need to write it as a fraction of an hour, so I need to do 75 divided by a third. So the distance that he travels is going to be, what am I doing? The speed, 75, times by the time, which is a third of an hour. So 75 times by a third, you can either do it on your calculators or just divide by 3. So that would give me 25 kilometers per hour. So the distance is 25 kilometers per hour. So 20 is the distance that you start at. So 20 plus 25 kilometers is 45 kilometers. So you know you're going to end up here, over there. I haven't worked out the time yet. And the time is 20 minutes. So from 10:25 to 10:35 is 10 minutes, to 10:45 is 20 minutes. Okay, so this is where you want to end up. I'll just get rid of these two. And you use a ruler to make sure that the line is straight. I don't have a ruler on my iPad, so I'm just going to do the, oh no, it deleted it. I'm just going to do the best that I can. So let's just check, that's from 10:15 to 10:25, right? So you start from where you are and then you just go up like that. Okay, so a distance of 25 kilometers. You know it's 20 minutes. So that's all you do to work it out. You don't have to work out the exact gradient because that's automatically worked out for you by working out the end point. And that's the completed travel graph. Okay, so here we've got a table of values. Now, all that means is that you're given some x coordinates and you use them to work out their corresponding y coordinates. So this is the equation of the line. So you're trying to figure out what y is when x is a certain value. They've done -2 for you, 0 and 3. So the best thing to do is always start from the positives because it just builds up your confidence and it makes you feel better because you're dealing with positive numbers. So y would be 4 squared, take away 2x, which would be 2 times 4, plus 2. So all you're doing is you're substituting 4 into the equation. So 4 squared is 16, 2 times 4 is 8, plus 2. So 16 take 8 is 8 plus 2 is 10. So that's the missing value for this one. Next, we substitute 3 into it. So y would be 3 squared, take 2 times 3 plus 2. So what's 3 squared? 9. 2 times 3 is 6 plus 2. So 9 take 6 is 3 plus 2 is 5. Oh, they've already done that one for you. Okay, so let's do it with 2. Just get rid of that working. So y equals 2 squared, take 2 times 2 plus 2. So that would be 4, take 4 plus 2, which would be 2. So that would be your missing coordinate there. Then we've got 1. So y would be 1 squared, take away 2 times 1 plus 2. 1 squared is 1, 2 times 1 is 2 plus 2. So that would just leave you with 1. And then we've got negative 1. So y would be negative 1 squared. So remember, a negative times a negative is going to give you a positive. So that would be positive 1. Take away 2 times negative 1 plus 2. So negative 1 squared is just going to be 1. 2 times negative 1 is going to be negative 2 plus 2. So remember, when there are two negative signs next to each other, they turn into a positive. So 1 take negative 2 is the same as adding 2. So 1 plus 2 plus 2 is 5. And what you should see is that there's it's a quadratic. So a quadratic graph is always going to kind of look like this, something like this, because it's symmetrical, because a negative number squared is the same as its positive counterpart. So like negative 2 squared is the same as 2 squared. So it forms a symmetrical pattern. So that's all we have to do for this part of the question. And on the next page over here, I've already filled in the graph with a table of values. And what we need to do is draw the graph of y equals x squared plus 2x plus 2. That's what you use a table of values for, so that you get your coordinates so that you can plot it. So your x coordinate is negative 2, your y coordinate is 10. So we go along the x-axis and up to 10. Then you've got negative 1 and 5. Then you've got 0 and 2. Then you've got 1 and 1. Then you've got 2 and 2. 3 and 5 and 4 and 10. So it's a quadratic. You know it's a quadratic because it's got an x squared in it, okay? And quadratics, remember, should look kind of like that. So when we join it up, that we need to make sure there's a smooth curve as we join it up. Okay, there we go. So that's drawn the graph. And now it's saying use your graph to find estimates of the solutions of the equation x squared take 2x plus 2 equals 4. So what that means, this is like solving simultaneous equations. So this is your line y equals x squared take 2x plus 2. And what they want you to solve is the line y equals 4. Okay, so they want to know what the solution is when this curve meets the line y equals 4. Okay, over here. So what we want to do is draw the line y equals 4, which is over here. Remember, the reason it's called y equals 4 because any point you have here, the y coordinate is going to equal 4. That's why it's called the line y equals 4. So what we do, it's going to be a bit hard because it's on an iPad, but the solution is always where the two lines intersect. Okay, so solutions of any kind of graphical equations is where the lines intersect. So let's look at this. Now this is a bit of a nasty one because it's not, obviously you will be much more accurate because you have it on paper. So I would say that is, so negative 0.5 is here, 2.5 is here. So I would say the x solution would be 0.7, anything between 0.65 and 0.8. So I'm going to go for, negative 0.65. And over here, I'm going to go for 2.5, 2.6. I'm going to go for 2.7. Okay, but that's, this is, so for the first one, you would, they'd give you an accuracy mark of anything between negative 0.65 and negative 0.8. And then for this one, you'd have an accuracy mark of anything between 2.65 and 2.8. Okay, so as you can see, there is a little bit of leeway there, but that's how you find your solutions. You make it equal to the line. So in this case, you've got your graph and you make it equal to the line y equals 4. If over here it said equals 8, you draw the line y equals 8. If it said negative 7, you draw the line y equals negative 7. And you just find the two solutions, and solutions are where the lines intersect. And that's how you solve simultaneous equations on a quadratic graph. Okay, so here we've been given a right angle triangle. Now, when I've been given a right angle triangle, it usually means it's going to be one of two things. It usually means I'm going to either have to use Pythagoras or trigonometry. Because there are no angles involved, I'm going to go for Pythagoras. But obviously, if I untangle the question, it will become really apparent if it's going to need to be trigonometry. So I'm told that I've got a right angle triangle with side lengths 8 and 10, and that the shape below is made of two of these triangles. And I need to work out the perimeter of the shaded shape. Okay, so the perimeter is, remember, the distance around the outside of the shape. So I've got 8 here, 8 here, 10 here, and I'm going to need, my missing sides are this, which is equivalent to the hypotenuse over here. And then this little extra bit here, which we're going to talk about. So first, let's figure out what the hypotenuse is. So Pythagoras' theorem is just a squared plus b squared equals c squared. So a and b are the two shorter sides and c is the hypotenuse. So you might want to write it as a squared plus b squared equals h squared if it helps you remember it better. But either way, c or h or whatever is the hypotenuse, the longest side. So 8 squared plus 10 squared is equal to c squared. So 8 squared is 64, 10 squared is 100. So therefore, c squared is 164. So this is a calculator paper. What you do is to find the inverse of something that's been squared, you square root it. So it's that button there. You type in the square root button, and the square root of 164 is going to come up as 12.80624847. Okay, so that's the side length over here. So let's just say 12.8. And now what we need to do is figure out what that missing length could be. So obviously we know that the hypotenuse of the triangle is 12.8. So let's choose a different colour. So this whole length here must be 12.8 because it's made of identical triangles. So that whole length there is 12.8. But also I know that the base of the triangle, so let's use a different colour, just this part here must be 10 millimetres. Okay, so that means that if I've worked out that the hypotenuse of the triangle, so the pink line is 12.8, and the base of this slanted triangle is 10, then I just do 12.8, well, 12.8, blah, 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 take away 10, which leaves me with 2.80624, blah, 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 blah. Helps to just have that. If you don't know how to save it into your calculator, you just write it out manually. Okay, so to work out the perimeter, I have to do 8 plus 8 plus 10 plus 2.8 plus 12.8. So let's do that. 12.8 plus 2.80624847 plus 8 plus 8 plus 10 would give me 41.612. 41.612, blah, blah, blah. And they have said, give it to correct to 3 significant figures. So 3 significant figures, I would say that is 41.6. So look next door, it's less than 5, it's less than 4, so I just ignore it. I just get rid of it and I round it as 41.6. And that's how I'd solve that question. Okay, so here I have another right angle triangle and it's got angles involved, so it looks like I'm going to be using trigonometry. So I've got an angle and a side, and I'm being asked to work out the length of BC, so this line here, and give my answer to 1 decimal place. So with trigonometry, hopefully you know the little SOHCAHTOA, so that just helps you remember the ratio, which things to use. So what I always do when I'm doing trigonometry, the most important thing is to label your triangle accordingly. So this is your given angle here, okay? So 56, this is your given angle. So you label everything based on that angle. Now the hypotenuse is always the longest side. It's always the side opposite the right angle, so that should be pretty simple. And then the opposite side is the one that is opposite your angle. So that's how we determine what the opposite side is. And then the one that's next to is your adjacent. That is, adjacent just means next to. So the side that is just next to it, and I kind of wrote over the 12, so I'll just write that again. So that is your adjacent side. Now to determine whether we use SOHCAHTOA or TOA, we just look at which sides we're using. So we have been given the adjacent side, which is 12, and we're trying to work out the opposite side. So in this case, we're using O and A, the opposite and the adjacent. So look at SOHCAHTOA, which one uses O and A? It's this one here. So that's how you determine which out of SOHCAHTOA you use. So then I write out the full formula. So tan theta is opposite over adjacent. So theta, that just means the size of the angle. And now what I do is I fill in the information I've been given. So tan 56 degrees, because that's the side of the angle, is the opposite. So I can just call that X, I could call it O, whatever you want. You don't know the value. So you just call it X and you say it's over the adjacent, which is 12. So now you've substituted your values into this formula. All you need to do is solve the equation. So when it gets to this, it's just all about solving and rearranging equations. So X is being divided by 12. So what would I do to get it on its own? I'd multiply both sides of the equation by 12. So I would be left with 12 tan 56. Now, all I need to do once I've done that, once I've got X on its own, is just type into my calculator 12 tan 56, close the brackets, and then you've got your answer. That is all you need to do. So that would be 17 point, oh, it says to 1 decimal place, so that would be 17.8, because the full answer is 17.7907, blah blah blah. You round it to 1 decimal place. So you circle the 7, you look next door, it's larger than 5, so you add 1 more. Okay, so that's how you do that one. This is with finding a length. Now the next part of the question, it's a different triangle, and we're being asked to work out the size of the angle. Once again, what's the most important thing? Well, first of all, we can write out our SOHCAHTOA just so that we have them there. It helps to remember. And then we label the triangle. So this is your angle here. You've been given this angle, and that's the angle we're going to work with. So we label everything according to this. So the right angle is here, your hypotenuse is over here because it's always the one opposite the right angle. And then this is the side that is opposite your given angle, so that's the opposite side. And this one is adjacent, next to the angle that you've been given. Okay, so we are trying to work out the size of angle X, and we've been given 2 sides. We've been given the hypotenuse, that is 18, and the adjacent, which is 15. So A and H, which one has A and H? That's K. So let's write out the equation. Cos theta is adjacent over hypotenuse. And then let's fill in what we know. So we don't know the size of theta, that's the angle. So we could just say cos X, because that's the name they've given to it, is the adjacent, which is 15. The hypotenuse is 18. And then what do? We need to get x on its own. So this is where you can't divide by cos on the calculator. So what you have to do is type in shift. So the shift button and then cos, and that gives you the inverse of cos. So it's essentially like dividing by it. So x would be, I'm just going to write it out here, shift button cos. That's when we're trying to work out an angle and we're dividing, gives you the same effect. So dividing by cos, shift cos, and then 15 over 18. Type that into your calculator and it should give you 33.557, blah, blah, blah. Again, it says to one decimal place. So we say 33 point, look at the 5, look next door, it's larger than 5. So we add one more, so 33.6. Okay, so in this question, we're dealing with density. So it's good to know the formula for density, which is density is mass over volume. Okay, so we're told that liquid A has a density of 1.8 grams per centimetre cubed and B has a density of 1.2 grams per centimetre cubed. Now, another quick way of remembering the formula, if you've forgotten it, is here they kind of tell you like how density has to be written. So density is written by grams, which is mass, over volume, which is centimetres cubed. So if you forget, then hopefully you can use that as a little trick to remember. They're told that 80 centimetre cubed of liquid A is mixed with 40 centimetre cubed of liquid B to make 120 centimetre cubed of liquid C, and we need to work out the density of liquid C. Now this is where a lot of people kind of get wrong, because they're like, oh, I'll just add up the densities of liquid A and B and divide them by 2 and that'll give me liquid C. No. What we need to do is use the information we've been given to find the information that we don't know. So if we set ourselves up a little grid, so liquid A, liquid B, we know that, oh, I've done this wrong. I'll just do it again. Okay, so we need 3, so liquid A, liquid B. So density, mass, and volume. And this way we're not missing out any information. And we could do one for C for the final part. So the density of liquid A is 1.8 grams per centimetre cubed. We don't know the mass, but we know that we're going to be mixing a volume of 80 centimetre cubed. And for liquid B, we know it has a density of 1.2 grams per centimetre cubed. We don't know the mass, but we know we're going to be mixing a volume of 40 centimetre cubed. So what we can do is use our formula to work out the missing information. And let's just quickly rearrange it. So density is mass over volume. It's mass that we're looking for. So mass will be density times volume. Okay, so in this case, to work out the mass of liquid A, I would do 1.8 times by 80, which is 144. So that liquid A must weigh 144 grams, and liquid B must weigh 1.2 times by 40, which is 48 grams. Okay, so I know that the volume of liquid C is going to be 120 centimetre cubed in total, and its total mass is going to be 144 plus 48, which is 192 grams. So now I just need to work out the density. So density, remember, is mass over volume. So the mass is 192 over 120. 192 over 120 is 1.6. So that'd be 1.6 grams per centimetre cubed. And that's your final answer. Okay, so in this question, we're being asked to criticise a graph that someone has drawn for cumulative frequency. Now, the key thing for cumulative frequency is that it's like the running total. So let's say in this case, what is it? The minutes taken. So let's say it takes 5 people under 10 minutes to solve a puzzle, and then 8 people between 10 and 20 minutes. The cumulative frequency means that 13 people have taken under 20 minutes. So it includes everything that comes before that. Okay, so that's the whole point of a cumulative frequency. Here at the moment, this is just a grouped frequency table that tells us between 10 and 20, between 20 and 30, how many people. Cumulative frequency brings it all together. So it's a running total. So the frequency is always going to get larger. So this is the table that Brian drew. Write down one thing that is wrong with this cumulative frequency table. Well, it's not a running total. So his inequalities should be 0 to 10, but then it should be 0 to 20, 0 to 30, 0 to 40. Okay, so the cumulative frequency should be the running total. So that would be 5, but then this would be 5. Oh, no, he's got that right. So he's got that right. So he's added the cumulative frequency, but because he hasn't changed the inequalities, he's implying that 50 people took between 50 and 60 minutes. That's just not true. 50 people took between 0 and 60 minutes, okay? So the thing that is wrong here is there is an error in the inequalities. They should be from 0. Should all be from 0. Because it's a running total. It's everything that's included up until now. So this final column should be how many people took between 0 and 60 minutes, because it's including everyone. Okay, so that's the main thing that's wrong with that over there. Okay, so here we've got a box plot. So a box plot is just another way of representing data. It shows information about the length of time some people waited to see a doctor on hospital, and we need to work out the interquartile range. Now the interquartile range is worked out by just finding the upper quartile and subtracting the lower quartile from it. So the upper quartile and the lower quartile are represented by the ends of the box. So this would be the lower quartile, and that would be the upper quartile. And the little whiskers, that's the end of the data. So that would, this here would be the largest piece of data. That's the smallest piece of data. And the middle part is the median. Okay, so that's a box plot. So we need to work out the interquartile range. So the upper quartile is, let's try this really carefully. So 160 is over there. This would be halfway, so that's 180. And my line is 2 boxes out. So between 180 and 200, there's a difference of 20. And there's 1, 2, 3, 4, 5 boxes. So 20 divided by 5 is 4, which means that each little square represents 4 people. So that should be 188. So the upper quartile is 188. And the lower quartile, let's delete that arrow so I can see. The lower quartile, oh, that's going to be a middle one. Okay, so that's 44, 48, 50. Okay, so that would be 188 take away 50. So if you look really closely, you can see that it's in between, it's not exactly on a line, it's in between 2, so it's halfway. So if one box is 4, then half a box would be 2. So the interquartile range would be 188 take away 50, which is 138. And that's how we work out the interquartile range. It's the difference between the top 75% of the data and the bottom 25% of the data. So it's the spread between the middle 50% of the data. Now Becky says 50% of the people waited for at least 2 hours. So we need to figure out how many people there are in total. So this over here tells me the maximum amount of people, which is 200. So 200 people in total. And 50% of that is 100 people. So we just need to know that more than 100 people waited for at least 2 hours. So what's 2 hours in waiting time? 2 hours is 60 plus 60, which is 120 minutes. And we know that the median here is at 120 minutes, which is 2 hours. So that means that exactly 50% of the people waited for at least 2 hours, because the median is 50%. That's 50% of the data. So yes, Becky is correct, because the median is at 2 hours, and the median represents 50% of the data. The upper quartile is 75% and the lower quartile is 25%. So in this question, we're being asked to compare the distributions of the lengths of time. So we're being asked to compare data. Now, when we're asked to compare data, we want to compare something in particular. So the median is a good thing to often compare, or the lower quartile or the upper quartile, or the spread of the data. But we are told that Becky was asked to compare the distributions of lengths of time people waited on Monday with what they waited on the Tuesday. So the Monday information is the box plot, and the Tuesday information is what we've been given here. Now, we know that the shortest time, so what we could do is we could draw ourselves a little extra table just to compare everything. So this is for Tuesday, this is for Monday. So the shortest time on Tuesday would be 0:20. Okay, so the same shortest time. We already said the lower quartile was 50. The median is 120. The upper quartile, what did we say it was? It was 188. And the longest time here was 200. Okay, so she's saying people had to wait longer on Tuesday than on Monday. Well, even though the longest time is 210, both the upper quartile and the median are lower, which implies that the top 25% of people actually waited for a shorter amount of time. So the easiest thing to do when giving a reason is compare the median. So what's happening to the median? Well, she might be wrong, because the median is lower on the Tuesday, which implies that there could have been, the average people would have waited less time. So we don't know, because we don't know all of the data, but we could either say the median is lower on Tuesday, or we could have said the upper quartile is lower on Tuesday. So when you're comparing, what you want to do is pick a piece of the data, so the median, the lower quartile, the upper quartile, and say how it compares to each thing. So either of those reasons would be fine. Okay, so this question is about compound interest, and all that means is that so compound interest is actually a really, really cool thing if you're saving money and you have a good savings rate, but not a good thing if you've got debt. So what compound interest essentially means is you have a pot of money. Let's say you have £100, you have an interest rate, let's say £5. So at the end of the year, you will have basically got £5 for free in interest. So your money would be worth £105. So you'd have £105 in the bank account. Now, at the end of year 2, you'd be getting 5% on that £105. So the amount that you'd get at the end of year 2 isn't £110, because it's not 5% of £100, it's 5% of £105. So your money kind of grows year on year. So that's the kind of basics of compound interest. So over here, we're told that Louise invests money in better investments for 3 years, and Sadiq also invests for 3 years. And we know that at the end of the 3 years, the value of Louise's investment is £344,605. So Louise is investing in better investments. So because we are told that they both invest X amount, that implies that they both invested the same amount. Okay, so what we have to do is reverse engineer, go backwards to figure out what amount Louise invested. So Louise invested X, so whatever she invested, we'll call that X, and she invested it for 3 years. So the important thing with compound interest is basically you work out what the percentage multiplier is, And to do that, you'd say, okay, so there's an interest rate of 2.5% per annum. So your original amount is 100% because that's 100% of what you put in. And then the interest is 2.5%. So 100% plus 2.5% is 102.5%. Now, what does percent mean? It means divided by 100. So 102.5 divided by 100 is 1.025. So hopefully you're familiar with multipliers. If not, then basically add the percentage of the interest onto 100% and then turn it into a decimal. So that's my multiplier, 1.025. And the formula for compound interest is basically the original amount times by the multiplier to the power of however many years there is. Okay, and the reason we do that is because instead of multiplying it by 1.025 and then 1.025 again, which I can do, I could do times 1.025 times 1.025. The shortcut is you just do it to the power of 3 because it's the same thing. So I'd say x times 1.025 to the power of 3 equals 344,605. So what do I have to do to find out what x is? Well, x is being multiplied by 1.025 to the power of 3. So all I'd have to do is divide both sides by 1.025 to the power of 3. So 344,605 divided by 1.025 to the power of 3 gives me 320,000. So x is 320,000. Okay, so that's the original amount. So that means that that is what Sadiq also invested, because they both invest X amount of money. And in any maths question, if they use the same algebraic variable, so X or Y, then it means it's the same amount. So X is the original amount for Sadiq. So I'm going to say 320,000 times by, okay, so an interest rate of 2%. So remember, you do 100% plus 2%. That's 102%, which would be 1.02 if you just divided it by 100. So times 1.02. So I can either do to the power of 2, but I'm just going to do it twice just to show you how you can do it another way. So I could have said to the power of 2, or I just write it out twice. It doesn't matter. But because that's for 2 years, I do that twice. And then the percentage multiplier for 3.5%, do the same thing. You've got 100 plus 3.5, so that would be 103.5%, so that would be 1.035. So it's really good to understand how you do the percentage multipliers and why, and to stick to this method that I've shown, because a lot of people skip the 0 by accident and they put 1.35, or they get a bit confused because there's a 3.5. So just stick to that method. So for each extra year is 1.035, and it says it's for 3 years, so we only do that once. And then I just type this calculation into my calculator. So 320,000 times by 1.02 times 1.02 times by 1.035 gives me 44,580.48 £. And that's how we'd do that one. Okay, so over here we've got a sketch of a line graph, and we've been told some points. So we've been told that P is -6, 0, Q is 0, 3, and they're all on the point on the line L. Now the point R is such that PQR, the line PQR is a straight line, and PQ to QR is 2 to 3. So 2 parts to 3 parts. Okay, so PQ is worth 2 parts. So let's figure out what the distance between PQ is. So the X distance, so let's take it one coordinate at a time. The X distance is from -6 to 0. That's a distance of 6. And the Y distance is from 0 to 3. Okay, so we know that the X distance is 6, the Y distance is 3. So that means that 1 part, so let's do this for both. So that's for the x coordinates. And that can be for the y coordinates. So a distance of 6 is worth 2 parts. So that means that each part is worth 1. So let's fill that in here. So that must mean that the x distance on line R is going to be 9. And then the y distance, so the y distance is 3. So 2 parts are worth 3. So that's 1.5, 1.5. And 1.5, 1.5, 1.5. Once we figure out how much one part it is, we can figure out what everything is. So that would be 4.5. So therefore we need to find the coordinates of R. So the coordinates of R would be 9 extra parts from 0. So from 0 to R would be 9. So the x coordinate would be 9. Because my starting point over here is 0. So from 0, 3, I'm going to add on 9 to the x coordinate and 4.5 to the y coordinate. So that would be 9 and 7.5. There are lots of ways of doing this. This is just done one way with ratio. It might be ratio that you need to touch up on if this isn't making sense, or just an understanding of the graphs. Okay, so in this question, we're being asked to find an equation of the line that is perpendicular to line L. So, same graph that we've been dealing with before. Just now we need to find an equation of the line that is perpendicular to it. So first things first, we need to know that every line can be written in the form y equals mx plus c, where m represents the gradient and c represents the y-intercept. So all that means is where the line crosses the y-axis, where it intercepts the y-axis. And y is literally just the y-coordinate at any given part of the line. And x is just the x coordinate at any given point of the line. So, first of all, what we need to do is work out the equation of the line L. So, there are a few ways we can do this. Which way should we do? Y equals mx plus c. Let's work out the gradient first. So, the gradient is the distance, or the change in y over the change in x coordinates. So the change in the y coordinates, well, it goes from it goes from 0 to 3. So that's the change in the y. And the x, it goes from -6 to 0. So that's 6. So the gradient is going to be the change in y, which is 3, over the change in x, which is 6. So that's a half. Okay, so we can start filling bit by bit in. Y equals a half x plus c. And now c is just the y-intercept. So where does the line cross the y-axis? It crosses the line, the y-axis, at 3. So it's going to be y equals a half x plus 3. That's the equation of line L. Okay, now the thing about perpendicular lines is that their gradients multiply to make -1, or another way to say it is it's going to be the negative reciprocal of the gradient. So a half, the reciprocal of that would be 2 over 1. You just flip it, and remember, any number you can write as a fraction. So it is 2, but I'm just showing you why it's 2, because it's the reciprocal, and it's a negative reciprocal. So the equation of line L is going to be minus 2x plus c. And I'm told that it passes through Q. Well, that's very nice that they tell me that, because that means that it's got the same y-intercept, because that would be where the perpendicular line crosses. So therefore, the equation of the line is going to be y equals negative 2x plus 3. So that is the equation of the perpendicular line. And the key thing to know here is the gradients of perpendicular lines multiply to make negative 1. So either remember that or remember that they are the negative reciprocal. So you flip it and stick a negative sign in front of it. Okay, so expanding triple brackets. This isn't as scary as it looks. All you have to do is multiply, pick 2 of the brackets to multiply and just expand them like double brackets. And then I'll show you what to do next. So for the first one, let's just multiply these brackets. We've got x take 2, 3x plus 2. Let's multiply them. So x times by x is 3x squared. X times by 2 is 2x. Negative 2 times 3x is negative 6x. And negative 2 times 2 is negative 4. Let's clean it up. So simplify and bring together your like terms. So that's 3x squared. Take 4x, take 4. Now what we want to do is draw a little grid. And then multiply this, which is the product of the first 2 brackets. So we could rewrite this as 3x squared take 4x take 4. And multiply it by this bracket. Okay, so we've essentially multiplied that out to get one single bracket, and then we're multiplying it by our final bracket. So we've got our grid, and we are going to have 3x squared negative 4x. So 3x squared negative 4x negative 4, and I'm multiplying that by 2x plus 3. Okay, so you've got your little grid, and the reason the grid is really good is because it ensures you don't miss any terms out. When we're dealing with triple brackets, you've got a lot of terms to play with. Yes, a lot of people can just do it by multiplying out the bracket, but this just ensures that you don't miss any of the terms out, and it's just a safe, foolproof method of doing it. So we've got 3x squared times by 2x, so 3 times 2 is 6, x squared times x would be x cubed. 2 times negative 4 is negative 8, and x times x is 8x squared. 2x times negative 4 would be negative 8x. Then 3x squared times 3 would be 9x squared. 3 times negative 4x would be negative 12x, and 3 times negative 4 is just negative 12. Now the cool thing about doing it this way is that all of your, if you've laid it out in descending powers, so like x squared goes first and then x and so forth, then the little diagonals you're just going to simplify. So your answer would be 6x cubed, because there's no other like terms. Then you've got 9x squared, take 8x squared, which gives you positive x squared. Then you've got negative 12x, take 8x, which is negative 20x, and then you've got negative 12. And that's it. That's your final answer. So I would recommend, you can also do a grid method for multiplying out the first 2 brackets, especially if you're not confident with this method, with multiplying brackets. Just do it with a grid, because then you don't miss out any terms. But that's how we do that. Okay, so this question is asking us to use the product rule for counting. So we're told that there are 16 teachers and 220 students. Of these, 120 are girls and 100 are boys. One teacher, one girl and one boy are going to be chosen to represent the school. Work out the number of different ways there are to choose one teacher, one girl and one boy. So the key thing here is that we are using the product rule for counting. So in probability, when you have the word and, generally it means that we're going to be multiplying the numbers together. So we've got one teacher, so there are 16 teachers. We've got how many girls? 120 girls. And we've got 100 boys. So we want to figure out how many ways, different ways there are to choose one teacher, one girl and one boy. Basically, if we had 16 teachers, each individual teacher could be paired with each of the 200 girls. So let's say it was 2 teachers, just to make it easier. Like, or just imagine 16 teachers going down. Anyway, the first teacher could be paired with 200 girls, okay? And any of that, 120 girls, 120. Any of those girls could then be paired with 100 boys. So there's a lot of options that could happen. So instead of writing that all out, which would be incredibly time consuming, all we do is multiply the possibilities. So if we multiply 16 by 120, we're essentially saying teacher 1, teacher 2, teacher 3, teacher 4, teacher 5, up to 16 is combined with 120 of the girls. So all we do in this case is we multiply. So we've got 16 times by 120 times by 100, which is 192,000. So obviously, I imagine there aren't that, I don't know why I wrote a money sign. I imagine there aren't that many people that would like to sit here working out 192,000 possible combinations. So instead of writing them all out individually and saying, okay, teacher 1 can go with student 1, girl 2, girl 3, girl 4, girl 5, and then out of that they can then also combine with boy 1, boy 2, boy 3. You just multiply them, okay? So this is the product rule for counting, and essentially if they're asking you to work out the possibility of this and this and this, and the key here is it's a multiplication, because it's that possibility and that possibility, which means you have to count for all of them. So quite simple if you know and you recognize that this is the product rule question. Generally, it's going to be where they're asking for a combination. So that's how you can recognize this question. And most of the time it's like done with a padlock. So they're like, oh, this it could be 10 numbers here, 15 numbers there. So if they're looking for a combination, that's where you're going to use the product rule. Okay, so here we've got a circle theorems question. So we're told A, B, C and D are 4 points on a circle. SBT is a tangent to the circle, and angle ABD is 20 degrees. And that the size of angle BAD, so this angle here, is to the size of angle BCD is 3 to 1. Now this is important because opposite angles in a cyclic quadrilateral add to 180 degrees. So this is a really good piece of information that we've been given. Opposite angles in a cyclic quadrilateral sum to 180 degrees. So if we know that, and we know they're in a given ratio, we can just work that out. So let's say 180 degrees is split into the ratio 3 parts to 1 part. So in total, it's split into 4 parts. So 180 divided by 4 is 45. So each little part is going to be 45 degrees. 45 degrees. So BAD is going to be 45 degrees and BCD is going to be 135 degrees. And now what we need to do is find the size of angle SBA. Okay, so we've got our 2 angles here. SBA is going to be all of this angle here. So we know that part of it is 20 degrees. And we know that the other part is here. So using the alternate segment theorem. Oh, I thought I'd done that wrong. Okay, so it's 3 to 1. So hold on. Sorry. It's the other way around. So the size of angle, this is BAD, 135 degrees. And this is BCD, 45 degrees. It helps, so you don't make the same mistake as me, it helps if you label things. So that's BAD and that angle here is BCD. So that's 45 degrees here. Okay, so we've got two angles in this cyclic quadrilateral. And we also see that there's a triangle here. So what's really important when we're doing circle theorems is to spot all the information that you possibly can. So over here, I've got a triangle. And now I can use the alternate segment theorem. So the alternate segment theorem states that the angle between a chord and a tangent, so this chord here, BD, is equal to the angle in the alternate segment. So basically what that means is, let's get a different colour. Over here, this line, this is the chord. So the angle that we're talking about in the alternate segment has to be an angle that doesn't touch that chord. So it can't be this angle or this angle here. Okay, it's in the alternate segment. So the alternate segment theorem states that these two angles are equal. So SBD equals BCD. So therefore SBD is 45 degrees. So we know that the total angle here is 45 degrees. And we just want to work out, what did we want to work out? SBA. So we just want to work out this little bit here. So if I know the total angle is 45, I subtract the angle that I have been given, the part of the angle that I've been given, which is 20. And that leaves me with 25 degrees. Okay, so the stages of your working, one, you know that opposite angles in cyclic quadrilateral sum to 180, and you used a ratio to figure out these two. And then the second part is the alternate segment theorem, where you know that the angle formed by the tangent, and this is a tangent, it's just a line that touches the circle, and a chord is just a line that goes from one edge of the circle to the other. So the angle formed by that is equal to the angle in the alternate segment. And that's how you do that question. Okay, so this question, we are given a triangle. It is a non-right angled triangle, which means trigonometry, Pythagoras, all of that is not going to work. So what I'm going to have to use is either the sine rule or the cosine rule. Now over here, I'm being asked to find the length, so I'm going to use the cosine rule. So I've got a squared is b squared, take c plus c squared, take 2bc cos a. Okay, so that is the cosine rule. Now, a really key thing when using the cosine rule or any kind of like trigonometry is that just because they have labelled the sides A or the angles ABC doesn't mean that you have to use that labelling. And in fact, really often it's not helpful labelling. So just because they've labelled it like that doesn't mean you have to. But in this example, it appears that they have actually been really kind and labelled it nicely according to the angle that we need. So what we do is with the cosine rule, the big letters, they represent angles, and the little letters, they represent sides. Okay, so in this case, the angle that we're given, that's always going to be A, the big A. So if, for instance, that was labelled B on the diagram, we'd cross that out and write A. But in this case, they've been nice. So what I do is label the sides accordingly. So that the side, the little letter is always the side opposite the angle. So big A is the angle, little a would be the opposite side. Big B is the angle, little b would be its side, and so forth. Okay, and once we've identified and labelled our triangle, all you are doing is substituting into the formula. So don't let these kind of questions kind of make you not want to do it. It's just substitution. And if you've labelled the triangle, it shouldn't be too difficult to just substitute the values in. So a squared, which is what we're trying to figure out, is b squared, which is 8. Or actually, let's do this. So let's label everything. So B is 8 centimeters, C is 11 centimeters, and big A is 72 degrees. So that just makes life easier for us. Okay, so B squared plus C squared, which is 11, take away 2 times B, which is 8, times C, which is 11, times cos 72. Okay, now all I do next is figure this out. So I could do it bit by bit just to make sure I don't do any calculation errors on my calculator. So 8 squared is 64, 11 squared is 121, 2 times 8 is 16 times 11 is 176 cos 72. So a squared is 64 plus 121. So I would, unless you're really proficient at calculators and you know how to do this, I would do it bit by bit, just so that you don't get something, make an error based on calculator. So 64 plus 121 is 185. Take, now into your calculator, type 176 cos 72. And that is 54.3869901. So a squared is going to be, you could do 185, take away ans. So that little answer button at the bottom over here, this is ANS, that stores your answer. So you could just type in 185, take away answer. That would be 130.613009. And then what do you do for the final part? You're going to square root it because a is being squared. So a is the square root of, once again, you could do the square root of answer, which is 11.42860, blah, blah, blah. But they've said give your answer to 3 significant figures. So a is 11.4. And that's how we do that. So obviously BC is equivalent to A. Okay, so and that would be, so this is a non-right angle triangle. So that's why it's really important. It's not just going to be base times height divided by 2, because this is non-right angled. So the formula for a non-right angled triangle, area of triangle non-right angled, is half AB sine C. Okay, so this is where the whole thing about rewrite your triangle in terms of what you want. So obviously C is the angle that I've been given, so I'm just going to change that to a C just to make my life easier. So I recommend crossing it out in your exam and just changing it. That could be A and that can stay as B, it doesn't matter. Okay, so the other sides don't really matter. What matters is they correspond. So C is my big side, big angle. So this is going to be my little side, this will be my little side, and that'll be my little side. Okay, so super helpful tip. This is where so many people go wrong. So just rewrite it in your own terms so it makes sense for you. So the formula for the area of a triangle is half AB sine C. We need to figure out the area. All we do is substitute our values in. So the area would be a half times by A. So let's just write them out again. A in this case is 11. B is 8. And big C is 72 degrees. Now this is why it's really important, because remember in the last one, the big C, the angle was A. It doesn't matter. Just rewrite it for whatever suits you, as long as each angle corresponds to its opposite side. So half times by A, which is 11, times by B, which is 8, times by sine C, which is 72 degrees. You literally just plug that into your calculator. So 0.5 times by 11 times by 8 times sine 72 is 41.84648672. But once again, you're asked for 3 significant figures. So your third significant figure is here. Look next door. It's less than 4, so you just ignore it, leave it, and that would be 41.8. Okay, so here we've got an iteration question, and with iteration it's essentially just substituting again. So over here we're told that n plus 1 is blah 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 blah. Okay, we have to substitute into that term, and we need to find the values of x1, x2, x3. So we can think of that as like the first term, the second term, the third term, and we start with x0 equals 2. So what we do, xn plus 1, well, if we start with x0, 0 plus 1 would be 1. So that would be the first term. And we substitute in, so x0 is going to be our xn term. Yeah, it's the first term. So x1 is going to be the cubed root of 10 take 2xn. So we are told that x to the power x0, the 0th part, is 2. So we're going to do 10 take away 2 times by 2. which is 10 take 4 is the cubed root of 6. So the first term is going to be the cubed root of 6, which is 1.817. 1.817120593. Okay, so that's the x1 term. Next, what we do is find the x2 term. So we type in the cubed root of 10, take away 2 times by whatever we just got. So that is 1.817, blah, blah, blah. Essentially, with iteration, what we're doing is we're constantly improving our answer, and we enter the last answer that we got, if that makes sense. So x2 is the equivalent of xn plus 1. So 1 plus 1 is 2. So it's a bit tricky to kind of explain, but hopefully you can see what I'm doing. So the answer to x1 is 1.817. And that's why I'm substituting it in here. So this part here is always going to be the previous answer, or the previous term. So let's work that out. So I've got the cubed root of, and what I can do here is just type in the cubed root of 10, take away, and then put in brackets 2 times answer. So then you don't need to go through writing it all again. So 10, take away brackets 2 times answer in your calculator gives me 1.853318496. So that would be 1.8533186, so forth. Okay, and the final part is x3. So we do the same thing, the cubed root of 10, take away 2 times by 1.853, our previous answer. So let's just use a different colour just to see. So I figured out that the previous term was 2, so I substituted it in here. Then, to improve my answer, I've got 1.817 and I substituted it in to find x2. Then I worked out that the answer is 1.816, so that is what I substituted into here. So each time you're substituting the previous term's answer. So anyway, that would give me 1.846265953. If you know how to use the shortcuts of your calculator, then you could just, you've got your equation set up, you could just delete the last part and just put answer in. But I'd rather you do it bit by bit and get it right than try and do some fancy calculator stuff. Okay, in this question, we have been told that the values we've worked out are estimates for the solution of an equation in the form x cubed plus ax plus b equals 0. So all that means is the formula that we've been given, which is over here, obviously had like to the power of n, I've just turned that into an equation. And what I need to do is rearrange it so that it's in this form here. So I've got x equals the cubed root of 10 take 2x. What's the first thing that I can do? I can cube both sides. So I undo the cubed root and I turn this into x cubed is 10 take 2x. What do I do then? I would add 2x to both sides. So x cubed plus 2x equals 10. And the final part would be, I would subtract 10 from both sides. So x cubed plus 2x take 10 equals 0. So now it's in the form. All I've done is rearrange this equation into this form. So remember, you can manipulate things as much as you like. And therefore, I've worked out the values of a and b, because the value of a is over here. If I just line them up like this, x squared plus ax plus b equals 0. So the value of a is 2. And the value of b over here is -10. So that's all I'd do for that. So if they give you something like this, you just rearrange the equation to give it in the form that they want. Okay, so here I've got a question on histograms. Now, the key thing about histograms is to understand that the frequency, and that just means the amount of, oh, I don't know why it's gone so big, this thing. So the amount of people or whatever it is in the question. So in this case, it's people. So some people took part. So frequency, to work that out, you do the frequency density times by the class width. Okay, so frequency density is going to be your y-axis, which is over here, and your class width is literally the width of the bar. Okay, so let's write that again. So the frequency, to work it out, it's the frequency density times by the class width. And another way of saying this, which is a lot easier, is the frequency is just the area of the bar. Okay, so this is the key thing to know when dealing with histograms. Now, we are told the histogram gives information about the scores of these people in the first round. 20% of the people got a score high enough for them to qualify for the second round. Work out an estimate for the score needed to qualify for the second round. Okay, so first of all, we don't know how many people took part in this competition. We don't know the frequency, the amount of people. So that's the first thing we're going to need to work out. So over here we have a okay, so each of these bars, if that's 0.5, each of these little squares must be 0.1. So 0.5, 6, 7, 8. So that's 0.8. So bar 1, I would do 0.8 times by 5 to give me the frequency. And 0.8 times by 5 is 4. So that means 4 people are represented by this bar here. The second bar is 10, the class width, times by, so that would be 1.5, 1.6. So that would be 16 people. Okay, the third bar, we've got 15 to 25, so that's a class width of 10, and 2.2 is my frequency density, so that would be 22 people. And the last one I've got from 25 to 40, which is 15, times by 1.2. 15 times by 1.2 is 18. Okay, so I've worked out the frequency. Now to work out the total of the number of people, so the total frequency would be 4 plus 16 plus 22 plus 18, which gives me 60. Okay, so I know, I'm just going to rub this out, so we know frequency is the area of the bar. I know that there is a total of 60 people. Okay, now it said 20% of the people got a score high enough to qualify, so I need to work out what 20% of 60 is. So I could just do 0.2 times by 60 if you know how to use your multipliers, or you use any methods you want for working out percentages. So 12 people scored high enough. So then these are going to be the top 12 people. So out of 60 people, the top 12 are going to be in this bar here. Now in total, this bar represents 18 people. And what is 12 as a fraction of 18? Well, 12 over 18, simplify it, is 6 over 12. 6 over 9, sorry. 6 over 9, which is 2 over 3. So 12 over 18 is the same as 2/3. So that means that I want to split this bar into thirds, and each little part here is going to represent 6. So the top 12 are going to be, and this is why it's an estimate, because obviously we don't know where these people are, how they're distributed in this bar. That's why the key word is work out an estimate. So that's how you do it. You're like, well, I know there's 18 people here, so I'll just split it into 3 parts. So the top 12 people must be in this part here. So an estimate for the score would be over here, 30. So 30 is an estimate for what they needed, because I'm assuming the top 12 people are in here. They're definitely going to be over 25, but the reason it's an estimate is because you split it up as fairly as you possibly can, and that's how you'd do that. So here we've got a trigonometric graph, and this is a trigonometric graph of the sine curve. So we're shown the graph between 0 and 360, but obviously it's a repeating pattern, so it's just going to repeat and do the same for infinity. Okay, so using this graph, find estimates of all four solutions of sine x is 0.6 for 0 to 720. Okay, well that's good because we only have the graph until 360, so we're going to have to kind of be a bit creative. So first of all, sine x is 0.6, so let's draw that. So that would be over here. This is terrible doing it on iPad, but let's see if we can kind of, so I know that's 0.6, so there, and so there. Okay, so what would that be? Well, I know this is 90, so that's going to be 30, 60. So that would be 30 going up in tens. Okay, so I'm going to say 37 degrees. But what matters here is whatever your accuracy is, as long as you're like doing a symmetrical part. So if you said this is 37 degrees and the opposite one here, it's a mirror, isn't it? So as long as it's whatever it is, it's subtracted from 180 on the other side, then it's fine. So if that's 37 degrees, then 180 take 37 gives me 143. Okay, so whatever your estimate here would have been, even if you're a little bit off, as long as the other part, so the mirror reflection of it is 180, take away your thing, then you'll be fine. Okay, or as long as it's not like really far off. Okay, so we've got 37 degrees and 143 degrees, and we know this cycle repeats. So we know that if we added on 360, because the whole curve is a cycle of 360 degrees. So where we are, it was roughly here, right? So where we'd get to be is roughly here. So that's 360 degrees further over there. So 37 plus 360 is 397 degrees. And then I do the same for 143 plus 360 is 143 plus 360 is 503. Okay, so you use this graph to figure out what you can. And then you know that the graph repeats itself every 360 degrees. It's like a repeating pattern. Repeating curve, oscillating. Okay, the next part is, it says the graph of y equals sine x is reflected in the x-axis. Okay, so if it's reflected in the x-axis, then it would be the graph y equals a negative sine x. Now, trigonometric graphs, there's a whole, to understand them, you really need to properly understand them. So if you don't know why, then watch the video that I've got on trigonometric graphs, because that will explain it. But basically, a reflection in the x-axis is the negative version of the graph. So it'd be y equals minus sine x. Okay, so here I've got a graph transformations question. Now, when we change the function, all this means is that we can do things to the x coordinate or the y coordinate. And the way that I know what is happening is where it is placed. So essentially, if so basically this is f of x, okay? So if something is happening like how it is here, if it's inside the bracket, then what that means is it affects the x coordinate and it does the opposite. Okay. If it was outside of the bracket, so if, for instance, instead I was asked to draw the graph of y equals f of x minus 2, then it would affect the y coordinate, and it does what you'd expect it to. But let's just stick with what we're doing. So in this case, it's inside the bracket, so it affects the x coordinate, which means I'm going to translate this graph along the x-axis, and it does the opposite. So over here it says minus 2. So what I'm actually going to do is add 2 to each x coordinate. And essentially what that means is I'm translating the graph 2 units to the right. Okay, so that's going to be a translation of 2 units to the right. So essentially that's minus 2. So that is going to move to here, 2 units to the right. That's negative 1. So that's going to move 1, 2 over here. This is 2. So that's going to move to 4. Oh. And that was negative 4. So that's going to move to negative 2. Okay, so all I'm doing is I'm translating the graph. The y coordinates stay exactly the same. It's just the x coordinates that I'm translating. That was a terrible attempt at a straight line. And that's all I do here. Okay, excuse the big blotchy line, but essentially, because the things are happening inside of the bracket, it means it affects the x coordinate, and it does the inverse of what it says. And that's how you do that one. Okay, so this is a scale factor question. So it looks like it's going to be about the volume and surface area, but you don't need to know the formulas. We're not working anything like that out. We're just looking at the scale factors here. So what I want to do is just draw a table for myself so that I can get all the information in a nice little table just to make life easier for myself. So I've got 3 spheres, A, B, and C. They've told me that the volume of the spheres is 125 centimeters cubed and 27 centimeters cubed. I don't know the volume of sphere C. So we've got surface area, and then we've got linear. So hopefully you've come across these scale factors, like you know that the linear scale factor is going to be x. So the area scale factor would be x squared, and the volume scale factor would be x cubed. If not, then watch my video on scale factors, and that will go through that all in detail. So I can do some working out here. So I know the volume scale factor. The volume of sphere A is 125 centimeters. So what I can do is work out the linear scale factor, because we're talking about ratios. Okay, so let's work out the linear scale factor. Well, the volume scale factor would be x cubed. So to get the linear scale factor, I would need to cubed root it. So the cubed root of 125 is 5. So the linear scale factor must be 5, and therefore the radius, the radius must be 5. I work backwards as well. So the cubed root of 27 is 3. So the radius of sphere B must also be 3. Now, let me just see if I can, yeah, I can just erase this bit like that. Okay, so what I want to do now is I've been given some extra information. I've been told about the ratio of sphere B, and the ratio of sphere C is 1 to 2. So sphere B to sphere C is 1 to 2, and I know that the radius of sphere B is 3. So what I do is I just apply my laws of ratio. That's going to be 2 lots of 3, which is 6. Okay, I've times both sides by 3. So the radius of sphere C is 6. Now what I need to do is work out the ratio of the surface area of sphere A to the surface area of sphere C. So I know that my linear scale factors are 5, 3 and 6. To work out my area scale factors, I would square them. So I only need to do that for A, which is 5. So 5 squared is 25. And the sphere C would be 6 squared, which is 36. So the ratio of the surface area of sphere A to the surface area of sphere C would be 25 to 36. And that's how I'd do this question. Okay, so here I've got a probability tree question. You don't need to use a probability tree to do this, but it just makes things visually a little bit easier. So in a village, if it rains one day, the probability that it will rain on the next day is 0.8. And if it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecast says there's a 70% chance that it will rain in the village on Monday, and we need to work out an estimate for the probability that it will rain in the village on Wednesday. Okay, so let's start off with Monday. So here we've got Monday. There's a 70% chance that it will rain in the village on Monday. So let's say rain, not rain. So that would be 70%, or I can work with, shall I work with decimals? Yeah, let's work. You can work with decimals or fractions or percentages, but probably easier to work with decimals. So let's just say 0.7 here. And the key thing about probability trees is the little branches, they have to add to 1. So the probability at raining is 0.7, not raining would be 0.3. Okay, so then I've got 2 options for Tuesday and 2 options again for it not raining on Tuesday. So it says if it rains on one day, the probability that it will rain the next day is 0.8. So if it's rained, the probability that it rains on the Tuesday would be 0.8. Therefore, the probability of it not raining would be 0.2. However, if it does not rain one day, the probability that it will rain on the next day is 0.6. So the probability of it raining is 0.6. The probability of it not raining would be 0.4. Again, just because probability branches, they have to add up to 1. So then on the Tuesday, I have, on the Wednesday, sorry, I have 2 options again. So if it's rained on the Tuesday, the probability that it will rain the next day would be 0.8. So rain, not rain, that would be 0.2. If it didn't rain on the Tuesday, the probability that it will rain the next day is 0.6. So rain, not rain is 0.4. And okay, again, the probability that it will rain the next day is 0.8. That's rain. Not rain would be 0.2. And if it didn't rain, then the probability that it will rain is 0.6 rain, and not rain would be 0.4. So I filled out my probability tree. Now let's see what possible routes I can take. So I want to work out the estimate for the probability that will rain on the village on Wednesday. So what are the options I've got? So it could be here, 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 or here. So all of these routes, I go back along them so I can figure out what it is. So if it rains on the Wednesday and it rained here and here, so that's one route. So I've got 0.7 times by 0.8 times by 0.8. So remember, when you're doing probability trees and you go along the branches, you multiply your probabilities. The second route I could have taken is rain. So here again, not rain and rain to get me to this one here. So that's 0.7 times 0.2 times 0.6. I'll change colours actually just so it's a bit easier. Another route I could have taken is, oh, I didn't want to delete it. Not rain, rain and rain to get me over here. So that would be 0.3 times by 0.6 times by 0.8. And then the other option would have been not rain, rain. So that would be 0.3 times 0.4 times 0.6. Okay, so I just type those into my calculator. I have 4 options of how it could get to having had rain on Wednesday. So 0.7 times 0.8 times 0.8 is 0.448. 0.7 times 0.2 times 0.6 is 0.084. 0.3 times 0.6 times 0.8 is 0.144. And the last one, 0.3 times 0.4 times 0.6 is 0.072. So they're all the probabilities, and what I do at the end, once I've worked out all the probabilities, I add them together. So that plus that plus that plus that. So add them all together, plus 0.144 plus 0.084 plus 0.448 is 0.748. So the probability that it will rain in the village on Wednesday is 0.748. Okay, so we're at the last question. You've made it to the very end, so well done. And what we've got here is an upper and a lower bounds question. So this is quite a tricky one because it's got quite a few moving parts. We're told that the formula used for this is t equals 2 pi times by the square root of L over G, and that Katie uses a simple pendulum in an experiment to find an estimate for the value of G. Now, what's important is that normally it would be nice if G was written as the subject of the formula, but it isn't. So we're probably going to have to rearrange. Here are her results, and the key thing is that it's rounded to 3 significant figures. So it's the third significant figure that we're going to look at in terms of finding the upper bound and the lower bound. So to start off with, what I want to do is rearrange the formula. So I've got t equals 2 pi times by the square root of L over G. First thing I could do is divide both sides by pi, by 2 pi. So t over 2 pi equals the square root of L over G. Now what I'm going to want to do is square both sides. Okay, so that would give me, let's do it here, t squared over 2 pi squared equals L over G. Now that would give me t squared, so 2 pi, 2 squared is 4, so that would leave me with 4 pi squared equals L over G. Now what I can do is multiply both sides by G, so G times by t squared over 4 pi squared equals L. And then what I have to do is divide by this part here, so G would be L divided by t squared over 4 pi squared. Now when I'm dividing a fraction, all I do is I flip the second fraction and I multiply it, so that would be G equals L times by 4 pi squared over t squared, and I can just simplify that as G equals 4 pi squared L over t squared. Okay, so that is my formula. So where shall I write that? I'm going to write that here. So G equals 4 pi squared L over t squared. So that's what I'm going to be using. And then let's get rid of this so that we can work out the upper and the lower bounds. So we've got the upper and the lower bounds are L. So L is 52.0 to 3 significant figures. So this is the part I'm interested in. So 52.0. I want to know what the upper bound and the lower bound is. Well, to 3 significant figures, what it would round to, if I rounded it up, would be 52.1. And what it would round down to would be 51.9. So therefore, what I want to do to find the upper bound and the lower bound is find the midway point of both of these. So the midway point is the point at which it rounds up to 52.0 and at which it would round down to 52.0. So that would be 51.95, and here it would be 52.05. Now there's a lot of contention around this, so technically it would be 52.049999 recurring, but generally we accept that it's going to take a long time to deal with that. It's going to be a little bit ghastly in terms of substituting, so it's accepted that when you're working with upper and lower bounds, the upper bound you can just write it as 0 as the 5, even though technically it would round up. So 52.05 would round up to 52.1, but the difference between 52.05 and 52.049 to infinity is so finite that we just accept that as like it's fine to write 52.05. So that's the lower bound, and that's the upper bound of L. And now we want to do the same with t. So t is 1.45, so let's do the same thing. 1.45 select 3 significant figures. So 3 significant figures obviously in this case means the 2 decimal places. So that would be 1.46 and that would be 1.44. So what's the middle of these? Oh, so over here, halfway point, that would be 1.445. That's raining quite heavily, and that would be 1.455. So that's the lower bound and that's the upper bound. And let's write these down here somewhere as well for our working. So for L, the lower bound is 51.95, upper bound is 52.05, and for T, lower bound is 1.445, upper bound is 1.455. So this is why this is a nasty question, because it's dealing with decimals, it's dealing with lots of little things, but at the end of the day it all comes down to substitution. So that's our lower and our upper bounds, and that's our rearranged formula. And what we're being asked is to find an estimate for G. So we want to work out the upper bound and the lower bound for the value of G. Now, if this is one of like the first times you're doing a bound question, then what I would recommend is substituting in each and everything. So for instance, substitute in the upper bound of L and divide it by the upper bound of T and then the lower bound of T. Then substitute in the lower bound of L and divide it by the upper bound and the lower bound of T. So essentially you get 4 answers and then you find out which is the smallest and which is the largest. But if you're quite used to bounds and you know kind of what you're doing, then to work out an upper bound, so essentially to get the largest value that we want to get the largest value we can on the numerator. So that would be the upper bound, let's write it in short-term slang, upper bound of L, and we want to divide that by the lower bound of T. So the larger the number divided by the smaller the number is the bigger your answer will be. And similarly, to get the lower bound, what we want to do is do the lower bound of L, so the lower bound of the numerator divided by the upper bound of the denominator. So obviously like 100 divided by 20 is 4. If I did 100 divided by 50, that would be 2. So that's why the lower you're dividing by, the larger your answer will be. But if this doesn't make sense, then watch the video on upper and lower bounds and it goes into more detail. But just as a quick thing, that's what we're going to be working with. So first, I'm going to do upper bound of L divided by lower bound of T. So let's do this. So G would be 4 times pi squared times L, and I'm dealing with the upper bound of L, which is 52.05. And I'm dealing with the lower bound of T, which is 1.1445, so 1.445 squared. So let's just plug that in to the calculator. So 4 times, oh, and you have to use 3.142 for pi. So 4 times 3.142 squared times by 52.05 equals divided by 1 and put in brackets 1.445 squared gives me 984.367. Okay, so that's going to be the upper bound. That's going to be 984.3677853. Okay, now what we're going to do is work out the lower band. So to work out the lower band, I am going to use the lower bound of L and the upper bound of T. So the smaller number on the numerator and the larger on the denominator. So G would be 4 times 3.142 squared. I put pi last time. I should have put 3.142 times by L. And what did I say I was doing? I said I was doing the lower bound, right? Yeah, 51.95 divided by, what is it, t squared? So 1.455 squared. So let's type that into the calculator. So 4 times 3.142 squared times by 51.95, and divide that by 1.455 squared is 969.0181643. Okay, so like I said, if this is a question that leaves you feeling unsure and you're like, I'm not going to be able to remember, it doesn't make sense to me, just do each of them bit by bit and you'll come up with 4 answers, and then obviously put the largest one as your upper bound and the smallest one as your lower bound. But that is it. So well done. Hopefully you found this video helpful, and let me know if you have any comments or suggestions or any topics you want me to cover in more depth.